Hello everyone, welcome to my channel. Let's solve this question together. Now look at what we are given on the board. We are going at the integral of what s divided by what x plus 1 with respect to what x, the x, right? That means we are asked to integrate this function with respect to s. That means the integral of what s divided by x plus 1 dx. That means we are going to integrate this function with respect to what x. This is integration, and this is what indefinite what integral, right? Because it does not require our upper, our lower, and our upper limit. So this is indefinite what integral. Now for us to solve this, I'm going to use two methods to solve this particular problem. One, I'm going to use what direct method, and two, I'm going to use what substitution method. Now let's use substitution method to solve this problem. Now our first step, what we're going to do, we're going to let the denominator here is s plus 1 to represent any variable. So do you know that we are not wrong? If you say let u equals to the denominator, which is x plus what plus 1. Now from here, let's make s the subject of the formula. If you're going to make s the subject of the formula, that means you have to subtract 1 from both sides, right? That means u minus 1 is equals to what x, because we subtracted 1 from both sides, right? We can call this equation 2. Let's call the equation 1, and also call this equation 2. Okay. Now from equation 2, let's differentiate u. From equation 1, let's differentiate u with respect to s. From equation 1, from what? From equation 1, equation 1, right? Let's differentiate u with respect to s. That means the u over the x will be equals to what? If you differentiate x is 1. If you differentiate a constant, remember, if you differentiate a constant in differentiation is always what? 0. That means if you differentiate 1 is 0. If you differentiate x is just 1, because the highest power of this x here is 1. So here is what? 1. So now let's make the u the subject of the formula. To make the u the subject of the formula, we have to cross multiply, or we multiply through by the x, right? That means the u will be equals to what? The x, right? Wow, this is genius, right? Amazing. I love this. Now let's go back to our real equation. Now the real equation is what? Is the integral of what? Now remember that our s is what? From here, you can see that our s is u minus 1. So that means this time become what? The integral of what? Now look at s you are seeing here, and we know that s from equation 2 is equals to u minus 1. So this is u minus what? 1 divided by, now s plus 1 is what? Now from equation 1, you can see that s plus 1 is u. So here is what? U. And what is the s? The s is the u. You can see that the u is equals to the s, and the s is equals to the u. So this is what? The u. Wow, this is amazing, right? Now I want you to understand something very interesting here. You can see that our numerator here is u minus 1, and our denominator is u. I want you to understand that this denominator is affecting u and also affecting minus 1. So by obeying some of the rules or some properties of this algebra, okay, this basis algebra, we can do something very interesting, right? Now this is now become what? The integral of what? U minus what? Divided by what? U minus 1 divided by what? U. Okay, now we can put them in a parenthesis, right? You can put them in a parenthesis, then multiply by what? The u. Can you see that this is interesting? Very amazing problem here, because since the denominator are the same, we can comfortably work on the numerator. Okay, this is very simple, right? Now we can see that we are all differentiating all this with respect to u. So do you know that we are not wrong, since we are having a minus sign here, that this is the same thing as what? The integral of what? Of u divided by u multiplied by what? The u minus the integral of 1 divided by u multiplied by what? The u. Wow. Can see that now we are differentiating u divided by u with respect to u, and we are also differentiating 1 divided by u with respect to what? U. This is news, right? Amazing. Perfect. Excellent. Now we know that u divided by u is 1. So that this now becomes the integral of what? 1 du, okay, minus the integral of 1 over what? U du. Wow. This is amazing. Now if we differentiate 1 with respect to u, is just u. Take note. When we differentiate 1 with respect to u, is just u. Okay. I know some people with that. Sagas, why is it that if you differentiate 1 with respect to u, you give us u? Now I want to show you something very interesting in this video. Now, do you know that by one of the properties of indices, it said that anything raised to the power of 0 is 1. Do you know that we are not wrong if we decide to write in place of u as what? U to the power of 0, and integrate it with respect to u? You can see that we have u. Now let's do it quickly. Now from here, do you know that we are not wrong if we decide to write this one as the integral of what? Of u to the power of 0, because u to the power of 0 is this one that's here. By obeying the properties of indices, then we are integrating with respect to what? With u. Then minus what? The integral of 1 divided by what? U the u. Wow, sorry, this is u, not the x. Sorry, the u. Wow, this is amazing, right? Now, if we integrate u to the power of 0 with respect to u, this is u to the power of 0 plus what, 1 divided by what, 0 plus 1. Then minus what? If you integrate this, now I want you to understand something very interesting here. Now, since we know that the numerator here is 1 and the denominator here is u, now this function is very simple. Now, for you, if the denominator here is 1, the denominator here is u. Now, remember that the numerator is already been differentiated by the properties of this function, right? And if we differentiate the denominator and it look exactly the numerator, that means we have to take the natural logarithm of the denominator. So since we know that if we the numerator here is being differentiated already by obeying the properties of this function, and the denominator here is u. So if we differentiate u, we will have 1, and 1 will look exactly the 1 as the numerator here. So if that is the case and is proper, that means we have to take the natural logarithm of the denominator, right? Now this now become what? Ln what into u plus what? Plus our integration constant c. This c represents most constant that were being differentiated that cannot be integrated anymore. Now let's simplify this further. So if you simplify all this, what this is u minus ln into what? U plus what? Plus c. Now this is our answer. But I want you to recall something very interesting. Recall that what is the value of u? Consider that u here is what? S plus 1. Wow. Can you see why substitution method is one of the amazing and one of the pocket-genius method of solving short problem? Now we recall that let u equals to s plus 1, and we are seeing that u is here. So we are comfortably to substitute s plus 1 in each of what? The value of what? U in place of u. Look at u we are seeing here. So u is what? Consider u is s plus 1. So we have this is x plus what? 1 in place of u. Then minus what? Ln here is what? U. So u is what? X plus what? Plus 1 plus our integration constant c. And this is the solution to this particular problem. Can you see that when you use the substitution method, this is the answer we have. We have that s plus 1 minus the natural logarithm of what? S plus 1 plus our integration constant what? C. And this is a beautiful solution to this particular problem. Wow, this is amazing. I love this. Now let's solve it by direct method. Let's see whether we can have the same answer. Maybe the answer will not be the same, but I'm telling you that whatever answer we have is the same thing, because if we differentiate this, we see the beautiful part of it, because this is, we are integrating, right? But if we differentiate it, you see the amazing proper of it, right? Now what we are going to do, let's use another method, the direct method, to solve it. So please permit me to remove this from here so that I can use the direct method to solve this, right? Now I want to clean this from here. Wow, this is amazing. I love this. Now we'll keep this answer here, then we'll use our direct method to see whether the answer will be the same. Then if the answer are not the same, we'll talk more about it, why the answer is not the same. Okay, all right. I love this. This is amazing problem. Okay, now the direct method is very short and simple. Okay, very short and simple. Now keep this answer safe. This answer is very important. Now from here, look at the amazing thing we are going to do at the numerator. You know that we are not so wrong. You are going to do amazing thing here. Okay, now first of all, look at the denominator. The denominator here is s plus 1, right? Do you know that we can do something very interesting to the numerator? You know that we are not wrong. We are not wrong in any way. If we decide to write this as what? The integral of x, okay, plus 1 minus 1 divided by what? X plus what? 1. The x, because we are integrating all this with respect to what? X. Now, do you know that we are not wrong? We are not wrong anyway, my brothers and sisters. Pay clear attention to this video. Because 1 minus 1 is 0. And x plus 0 is still x. We are not wrong. I know you ask, sir, why are you doing this? We are doing it because we are seeing there having a similarity as the denominator is x plus 1. Sometimes you'll be asking us, Saga, why did you add 2 minus 2 or 3 minus 3? The reason why I will not do that is because I'm concentrating on the denominator. Because the denominator here is s plus 1. So I have to do something similar to the numerator so that I can achieve what I'm looking for. Remember, I've told you in my previous videos that no man on earth hustles without nothing. If a man is doing a particular thing and that man is doing that thing regular, sometimes that man have a purpose why he or she, or let me say that person have a purpose he or she is doing that particular thing. So what you have to do is to calm down and look at that person. Guy, how far? Why are you doing this? You have a particular purpose why he's doing that, okay? See, achieve, because no man on earth is rugas, because everybody have their own purpose why they are doing a particular thing. So as I'm doing this, some people say, sir, why are you using 1 instead of 2? Because I know that you can still use 2 minus 2, and 2 minus 2 give us 0 plus s give us s. You can also use 3 minus 3, and 3 plus 0 and 3 minus 3 is 0, and 0 plus s is cs. I'm using this because The denominator here is x minus 1. If you can observe very clearly at the numerator, you can see that I'm having x plus 1 here, I'm having x plus 1. This is amazing, right? Amazing, right? Now look at what I'm going to do. Now I want you to understand something, that here is s plus 1 minus 1. So I can write it as what? The integral of what? S plus 1 divided by what? X plus what? 1 minus 1 divided by what? X plus what? 1. Remember, we are integrating this with respect to what? X. Wow, this is amazing. Now I can write something very interesting as what? The integral of s plus a divided by x plus what? S, integrating with respect to what? S, minus the integral of 1 divided by x plus what? S dx. Wow, this is amazing. Now if we divide the whole of this, we just have 1. So that this is the integral of what? 1 ds is minus the integral of 1 divided by x plus what? 1 then dx, right? Remember, if we do integrate 1 with respect to s, is just x. So we're going to add this is s, okay? Then minus what? If you integrate this, we're going to have what? Ln x plus what? 1, then plus our integration constant c. And this is the solution to this problem. You can see that when we use substitution method here, we have s plus 1 minus ln s plus 1 plus c. And here we use direct method as what? S minus ln what? Into s plus 1 plus what? C. Now you can see that the difference in this answer is just 1, but it's not bad. Yes, it's not bad. Remember, if you're working with differentiation, already you can see that we already integrate this. So you're working with differentiation. If you differentiate this, remember, if you differentiate the constant, it's always what? 0. Yes, so you can see, very simple, this answer are excellent what? Correct. Because if I want to differentiate this, right? If I differentiate s is 1, if I differentiate 1 is 0. Now if I differentiate this, if I differentiate s is 1. But there's no other one here. It's still the same thing. It's amazing. You see, it's amazing. So if your answer is this, and your answer is, if your answer is this, and your answer is this, they are correct. They are excellent what? Correct. And these are the beautiful solution to this particular problem. So thank you so much for watching. Please, if you find it very interesting, don't hesitate. Do well to like, comment, and so share it to loved ones so others will learn from it. Please, if you're not subscribed, kindly subscribe to this channel so anytime I have an exciting video, we notify. So thank you so much, and God bless you. Bye bye.